Welcome to Simplifying Complex Application Development using Cloud Firestore. My name is Nguyen, and I am a product manager for Cloud Firestore. We have an exciting session today that is composed of two major sections. The first section covers why Cloud Firestore and will include key challenges that Firestore solves for, along with a customer testimonial from Khanacademy. The second section covers what's new in Cloud Firestore, which will provide a sneak peek into exciting launches and a demo of an upcoming feature. Let's get started. Okay, face it, product development is hard. Not only do you have to focus on providing value through your core business, you also have to build complex applications composed of several components. Applications typically start with a database. This is followed by APIs in front of the database to handle client queries. Of course, you will have to keep your data secure, so you'll need to add an auth layer to manage both users and access to the APIs. Users expect applications to be real-time and collaborative, so you'll have to define a synchronization protocol. And finally, since users have intermittent network connectivity, you'll have to add support for offline mode as well. Often, these components are produced by several different vendors, and it's up to you to Lego brick them together. Now, if your application takes off, you have to ensure that your solution grows with demand. It often means sharding and scaling your solution, ensuring that your services are set up for high availability, and finally, managing major version upgrades and security patches, which will often incur some level of service downtime. What if product development could be made easier? I'd like to introduce you to Cloud Firestore, a purpose-built document database service that aims to make it easy to develop applications. Firestore is the successor to Cloud Data Store and incorporates technology from the Firebase real-time database for rapid application development. The service is available both through Google Cloud and the Firebase portfolio and provides seamless integrations with both ecosystems. So, what makes Firestore special? It's built to be serverless. That means it's a fully managed service that automatically scales based on demand and has no maintenance windows. It supports direct application to database connections and customizable security rules to ensure users can only access or modify the data that they're permitted to access. It has built-in live data synchronization and offline mode, making it effortless to build real-time applications that can withstand a network connectivity hiccup. And finally, Firestore has a rich array of supported libraries and frameworks, including those supported by Google and community-maintained libraries as well. One of the key attributes of Firestore is that it's serverless. From an external developer's perspective, Firestore offers a set of APIs for document reads, writes, and deletes. Behind the covers, the service decouples processing and storage layers in order to automatically scale both dimensions independently to meet demand. All data is stored across multiple strongly consistent replicas. In our regional offering of Firestore, that means having an availability SLA of 99.99%. In our multi-regional offering of Firestore, that means having a service that is resilient to whole region outage and an availability SLA of 99.999%. As applications perform additional read and write operations on the database uses automated load and range-based sharding to scale processing and storage with minimal impact latency. In practice, some customers have scaled to tens of millions of requests per second and petabytes of storage. More interestingly, Firestore is an elastic service that can scale resource utilization both up and down. As a result, customers only pay for what they use. No capacity planning is required. Getting started is also completely free, with a generous, always free tier to incubate your development. Often, I get the question, how is Firestore used in practice? Let's go through 3 common customer architectures. Okay, let's say that you want to use Firestore for its serverless attributes, but you prefer to architect your solution utilizing a more traditional approach that utilizes compute services to govern access to the database. Fear not, that setup is fully supported. In this architecture, access to Firestore is authenticated and authorized through Cloud IAM. Since Firestore is a transactional database, this architecture is often extended to support analytical workloads through a one-click integration with BigQuery that leverages Cloud Function triggers to stream data changes. What if you're an application development team that wants to reduce development time and total cost of ownership? In this diagram, you can see an architecture that achieves just that. Here, mobile applications communicate directly to the database, utilizing Firestore's client libraries. Authentication is handled through Firebase Auth or Google Cloud Identity Platform. Authorization is managed through customizable Cloud Firestore security rules. Syncing is handled through Firestore's persistent sockets to the database. Offline mode is managed through Firestore's on-device database. Similar to the last architecture diagram, to support analytical workloads, we recommend customers set up a one-click integration with BigQuery. If an application needs to present analytical results back to the end user, customers can execute BigQuery via Cloud Functions and store these results in Cloud Firestore. With live synchronization, the latest results will automatically be transmitted to listing application connections. If you already have an existing legacy application and database, but are facing challenges with high availability, scaling, or simply trying to build out features for your application, including real-time collaboration and offline mode, Cloud Firestore is for you. We are frequently seeing customers use Cloud Firestore in front of an existing legacy database to take advantage of these native capabilities. In this architecture, Cloud Firestore has been added as the primary serving database that stands in front of a legacy database system. To ensure that business processes can continue to run on the legacy database system, data from Cloud Firestore is often periodically synced using a pipeline service like Cloud Dataflow. Lastly, it's worth mentioning that Cloud Firestore is available in 2 modes. Both modes utilize a shared processing and storage layer. Data Store mode is fully compatible with Cloud Data Store. It's suitable for server to Firestore connections. Native mode consists of a new document and collections data model. It also works for server to Firestore connections. This is the mode that you want to select if you want to enable direct application to Firestore connections. Okay, we've covered a lot of information. Let's hear from a real customer. I would like to introduce you to Marta Kosarchyn, who is the Chief Technology Officer and Vice President of Engineering at Khanacademy. Marta will be sharing how Khanacademy has used Firestore to respond to a surge of demand of online education.
Hello, and thank you, Minh. I'll start by sharing a little about Khanacademy and our mission, and then I'll talk about how our use of the Google Cloud Platform, including Firestore, helps us to deliver on the mission. In particular, today I'll talk about how Firestore, along with App Engine for Compute, enabled us to scale rapidly in the explosion of usage of our site, beginning with shelter in place due to the coronavirus pandemic. For those of you not familiar with Khanacademy, we're an educational nonprofit, and our mission is to provide a free, world-class education for anyone, anywhere. Many of you will remember the origins of Khanacademy as founder Sal Khan described in his early TED Talks, YouTube videos that he made in his walk-in closet, motivated by his success in remotely tutoring his cousin over the internet. Today, we are much more than that collection of YouTube videos. Today, Khan Academy is the most effective solution for accelerating measurable learning. We offer free, interactive instructional learning materials and tools for core academic subjects from preschool through the first 2 years of college. We're a supplemental resource for teachers in the classroom through our personalized, mastery-based offerings, which focus on fluency of foundational skills and concepts. Efficacy studies show significant impact across elementary and middle school math and in SAT prep. And I'll pause for a few seconds to let you look at these numbers. In 2019, the Khan Academy website served over 94 million registered users in 190 countries. We had over 19 million monthly active users, which we define as users who spend at least 60 minutes during the course of the month on the site. We served over 240,000 teachers with content in over 40 languages, and there were over 15 billion practice questions completed on the site. In 2020, beginning in mid-March, as schools all over the world abruptly closed because of the pandemic, and students, parents, and teachers scrambled to move to distance learning, within just 2 weeks, Khan Academy site usage grew to 2.5 times what it was at the same time last year, and we've sustained that level through June. We were able to respond to this rapid growth, offering our high-quality content and classroom experience as usual for free. And in the month of April alone, we served 30 million learners on our platform. A recent national survey of parents found that Khan Academy was the most used online resource. I'm proud that we absorbed this rapid growth without disrupting our users, in addition to reacting quickly to alleviate pressure points within a few days. The Khan engineering team had prepared in advance, and that preparation paid dividends. We scaled readily in large part because of our architecture and a rigorous practice of choosing external services carefully and using them properly. Two fundamental components of our architecture serve us particularly well here: serverless and caching. We use GCP, including App Engine, Data Store, and Memcache, as well as other peripheral GCP services. And these three were the backbone of the serverless and caching strategy that's key to our scalability. As you can see in this diagram, serverless is a big lever for us. Using App Engine, a fully managed environment, means we can scale very easily with virtually no effort. Even with a substantial traffic increase, our site stayed up and performed well, with minimal intervention. We didn't need to worry about load balancing ourselves because server instances were brought up as needed. Caching also plays a key role in our scaling. We use Fastly CDN, which allows us to cache all static data and minimize server trips. Huge for scalability, it also helps us optimize hosting resources. We also extensively cache common queries, user preferences, and session data, and we leverage this to speed up data fetching performance. I know you want to hear about the third workhorse in our mostly effortless scaling, Firestore. Firestore scales out storage and access capacity automatically in much the same way that App Engine scales out web server instances. We spend very little time worrying about storage. Indeed, of the major parts of our system, it was the only one we didn't have to tune at all. App Engine scaling, Memcache, and task use did require a little tuning, although minimal. It's really hard to overemphasize how easily Firestore scales without us doing anything at all. We have no need to worry about resharding or ever about adding capacity. Here's a look at our June numbers to give you a sense of the scale of our data and site traffic, even in a summer slow month. Note the 5 to 10x daily scale out of site traffic. The auto scaling of both App Engine and Firestore helps us to minimize costs since we pay only for what we use. I'll end by sharing a couple of the amazing stories that our grateful users have been sharing with us about their experiences as the pandemic started. Here's one from a teacher. I'll pause to let you read that. And here's another from a doctor working on the pandemic front lines. And finally, I want to remind you that we're a nonprofit. Thanks for having me today, Minh. Back to you.
Thanks, Marta. It's exciting to see Khan Academy's broad impact at an acute time of need. The Cloud Firestore team is humbled to help customers like you make that possible. Next, I'd like to share some product announcements. We wrapped up 2019 with a class of features to support richer queries on Firestore. This includes collection groups, along with in an array contains any queries. We also added support for increment and decrement operations. More recently, we made it easy for Unity and C++ developers to adopt Firestore. It's also now simple to programmatically create Firestore databases using Terraform. And you can create those databases in 4 new locations, bringing our total global footprint to 19 locations around the world. Moving forward, a major theme of investment for Firestore includes metrics and performance optimization tools. To support this, we've launched usage dashboards and APIs to improve throughput of both bulk writes and read operations. One of the more exciting features that is coming soon is a new performance profiler for Cloud Firestore called Key Visualizer. And with that, I want to hand it over to Arash, who will be digging a bit deeper into Key Visualizer.
Thank you, Minh. Hi, my name is Arash Parsa, and I'm a software engineer here at Cloud Firestore. I'll be talking about Firestore Key Visualizer, which is an exciting new feature we will be launching the alpha soon. Cloud Firestore is built for automatic scaling and high performance out of the box. Still, sometimes when we talk to our customers, we hear statements such as, I'm experiencing median latency of hundreds of milliseconds for my lookup operations. Is that expected? Or I'm experiencing P99 latency of order of a few seconds for my write operations. Is that normal? And often the answer is no. We commonly find these performance problems to be due to the incoming traffic violating the service best practices. Let's use an example to explore one of the ways an implementation might violate these best practices. I'm a new Cloud Firestore customer, and I'm working on launching a new API. In this API, I would simply receive documents and store them in my Firestore database. In this case, I've implemented a function that generates the document IDs for me, and this function generates these document IDs incrementally. It's worth noting that we also find these incremental ID patterns often when customers are importing data from other databases such as MySQL, where auto-incrementing IDs are common. Let's see what kind of traffic pattern this implementation will result to. As you can see in this picture, this will result to a sequential write pattern in my key space. Keys are the full paths to your documents. So for any given document, the key is going to include all the parent collections in addition to the document ID, which is the last part of the key. Firestore is a range-sharded service, and at any point in time, your key space is going to map to a number of underlying shards. The undesired property of this write pattern is that at any point in time, your load is focused on a single underlying shard. Cloud Firestore supports sequential loads at up to 500 requests per second. At higher levels of load, this can result in hotspot, and for example, it can show itself in your API in the form of elevated latencies or errors. Cloud Firestore automatic scaling capabilities enables you to scale up your load to millions of requests per second. More specifically, by following our ramp-up guideline, which suggests to generally increase your load by 50% every 5 minutes, you can scale up your load to tens of millions of requests per second. Still, in a range sharded service, a sequential load pattern continues to map to a single shard and hence can result in hotspots. At Cloud Firestore, we are constantly working to provide you with better features that can help you diagnose this type of performance problems. We are excited to launch Key Visualizer in alpha soon. This tool provides you with visibility into the traffic patterns of your database across the key space and helps you self-diagnose a number of different performance problems. Let's go back to the customer story that we were just reviewing. So in preparation for my API launch, I've set up load tests that can hopefully represent the traffic that I'm going to receive during and after my launch. During these load tests, I start to observe that I'm experiencing some poor performance for my write operations. I jump to the Key Visualizer view in order to start the debugging process and get an understanding of where the root cause of the problem might be. Cloud Firestore Key Visualizer provides two-dimensional heat maps of your project's traffic. In these heat map views, the horizontal axis is time, increasing from left to right, and the vertical axis is your key space, with the lower key values located at the bottom and your largest keys located at the top. Firestore Key Visualizer heat map views are 2 hours wide. The heat scale at the top left provides the color coding that is used in this heat map. In particular, I can see that black or dark purple indicates that the metric value is one of the lower values, versus the glowing white, which indicates those regions are carrying some of the higher values for this metric. Firestore Key Visualizer provides a number of different metrics, including your total QPS, in addition to the QPS broken down for your write, lookup, and query operations. It also includes latency metrics for these three RPC categories. Going back to the example that we were just reviewing, I start by examining the write latencies metric. Using the provided color coding here, I can identify that there is a sequential load pattern that is accompanied with elevated levels of latency. In particular, I can find regions where the average latency can go as high as a few seconds. This is certainly not good and indicates that there is a serious performance degradation happening. Next, I switch to the write QPS metric. Using this metric, I can observe that this sequential load pattern is operating at higher than 5,000 requests per second. Thinking back about Cloud Firestore best practices, I recall that sequential load patterns are well supported up to 500 requests per second, but otherwise at higher levels of load, they can result in hotspots and performance problems. I can confirm with my application code that the document IDs within this collection are in fact being set sequentially, and this is the likely source and root cause of this performance problem. In this case, I will go ahead and change my implementation to use the Firestore auto-generated IDs, which are randomized by default, and redeploy my code to production. Next, I can use Key Visualizer to confirm that my traffic is now well distributed across my key space and that my latencies have moved back to the normal range. Okay, great. I was able to use Key Visualizer to efficiently debug and resolve a performance issue. Now, there are a number of other use cases that you can actually use Key Visualizer for performance debugging. For instance, in this case, as a customer, I'm able to quickly identify that collection foo is the one that is having performance issues. Even though my write operations look to be pretty well distributed in this case, it seems like there is another reason that my writes are performing poorly. I start by examining the documents which are being written in this collection. and identify that these documents are carrying a field that contains the time of insertion of the doc. Cloud Firestore indexes are strongly consistent, and hence they're updated at the time of your document writes. This means that if you're performing writes with documents that have sequential field values, those can also result in hotspots on your indexes. In the case that you have documents with sequential field values, you should either exempt them from indexing in the case that you don't need them for your queries, or in the case that you need them for your queries, you can partition those heavy write patterns, for instance, by applying a random prefix to those sequential field values. In the case that you use this technique, you would need to re-aggregate the result on the read side. Okay, so we reviewed a couple of examples where you might experience performance problems due to violating the best practices. Please continue to review our full list of best practices in order to make sure you're fully utilizing all the high performance capabilities that are built into Cloud Firestore. And now I'm going to hand it over to Minh to take us home.
Thank you, Arash, and thank you to all the viewers who joined us today. This concludes our session. If you haven't signed up for Cloud Firestore, we hope you take the opportunity to get started for free. If you have questions about today's presentation, please feel free to post your questions on the Dory. If you'd like to learn more about how customers are using Cloud Firestore, we encourage you to join the New York Times session, which will discuss how they utilize Cloud Firestore to power collaborative editing. And finally, we encourage you to join our large community of developers on Stack Overflow. Thank you.